Hey guys, today we're going to look at some terminal point trig. So one thing to remember is that the hypotenuse is always positive. No matter where your hypotenuse is always positive. Another important thing to remember is that theta is always made with the x-axis. Theta is always made with the x-axis. All right, so the first example says, find all 6 trig ratios for angle theta in standard position if the point 12,5 lies on the terminal side. So standard position just means that the initial side is out here on that positive part of our x-axis. And then we're going to pass through the point 12,5. So with that guy, I'm going to make a triangle, remember, with my x-axis, Now, to get to the point 12,5, I had to go over 12, so I know that length of my triangle is 12. And I had to go up 5, so I know that length is 5. So how do we find the last side of a right triangle? Pythagorean theorem, right? So we're going to do 5 squared plus 12 squared equals c squared. Or you know your Pythagorean triples, and you know that your hypotenuse is going to be 13. So as I mentioned before, theta is always made with the x-axis. So he's going to be right there, that angle made with our x-axis. Across from our angle is our opposite side. Across from the right angle is the hypotenuse. And the side that's left over is the adjacent. So now what we want to do is we want to find sine, cosine, tangent, cosecant, secant, cotangent. So sine is opposite over hypotenuse, so that'll be 5 over 13. Cosine is adjacent over hypotenuse, so that'll be 12 over 15, or 13. Tangent is opposite over adjacent, so that'll be 5 over 12. The next 3 are the easiest because cosecant is the reciprocal of sine, so just flip him over and get 13/5. Secant is the reciprocal of cosine, so we'll flip him over and get 13/12. Cotangent is the reciprocal of tangent, so we'll flip him over and get 12/5. Good deal. Now let's look at one that's a little bit different. It's the same problem, but this time my point is at -8, -15. So, still technically, my initial side starts here on that positive part of our x-axis. -8, -15 is going to be down here in this third quadrant. So I'm going to make my triangle with the x-axis and make theta with the x-axis. And we got to this point right here, -8, -15. To get there, we had to go left 8. So we're going to have a -8 on that horizontal part of our triangle. And then we went down 15. So we'll have a -15 on that leg of our triangle. Now, once again, we want to find the hypotenuse. So we have 8 squared plus 15 squared equals c squared. Or you know your Pythagorean triples, so you know that your hypotenuse is going to end up being 17. Remember, the hypotenuse is always positive. So right now, that 17 is positive, even if it's in the third quadrant. The hypotenuse is always positive. Cool, let's label up our sides. -15 is our opposite side. 17 is our hypotenuse. -8 is our adjacent side. Sine is opposite over hypotenuse, is -15 over 17. Cosine is adjacent over hypotenuse, so -8 over 17. Tangent is opposite over adjacent. So negative 15 over negative 8. You are not allowed to leave it like this here in a second. You are not allowed to leave it as a negative over a negative. You know better. You know a negative divided by a negative is a positive, so don't leave it like that, okay? I'm lenient about a lot of things, but that's one thing I'm not lenient about. That should be positive 15/8. So, cosecant is the reciprocal of sine, so it'll be negative 17/15. You can put that negative outside on the front. You can put that negative on the 17. You can put that negative on the 15. I don't care, as long as there's one negative somewhere in there. Secant is the reciprocal of cosine, so we'll have negative 17 over 8. Cotangent is the reciprocal of tangent, so it'll be 8 over 15. Good deal. Okay, now we're going to be looking at something kind of similar, but a little bit different. So suppose theta is an angle in standard position whose terminal side lies in quadrant 4. So first of all, we're starting out on that x-axis, and then our terminal side lies in quadrant 4, so somewhere over here. So what we're going to do is we're going to make our right triangle with our x-axis, and theta is always made with our x-axis. Cosine is adjacent over hypotenuse. So here's adjacent, here's opposite, here's the hypotenuse. Adjacent is 24, and the hypotenuse is 25. So then we can do the Pythagorean theorem. X squared plus 24 squared equals 25 squared. Or once again, you know your Pythagorean triples, and you get 7. Now, I know this side length is 7, but since I'm down in that fourth quadrant, I know my y's are negative, or I'm going to be going down 7, right? So I should have a negative on that 7. Cool, now let's just find all of our ratios. So sine is opposite over hypotenuse, so that's going to be negative 7 over 25. They already told us that cosine was 24 over 25, so yes, you need to put that in again. Tangent is opposite over adjacent, so that's negative 7 over 24. Good deal. Now we just flip them all over. Cosecant is the reciprocal of sine, so that's 25 over negative 7, or negative 25 over 7, whatever works for you. Secant is the reciprocal of cosine, so we'll flip over 24 25ths and get 25 24ths. And then we'll switch over that tangent to get cotangent, and we'll get 24 over negative 7. Good deal. Go ahead and try this last one on your own. Okay, so on these, I'm not worried about you rationalizing your denominators. So we found out that our hypotenuse was a square root of 544. So our sine is opposite over hypotenuse, and we'll flip that guy over to get cosecant. Cosine is adjacent over hypotenuse, and we'll flip that guy over to get secant. And then they gave us tangent, and we'll flip that over to find cotangent. All right, have a good day.